Let's summarize what we've learned today. First, U substitution converts one integral into an equivalent integral, and the goal is to convert the original integral into one that's easier to integrate. So, for example, in this integral, 3x squared sine of x cubed plus 1, we chose u equals x cubed plus 1 because that allowed us to convert the integral into just sine u, and we all know the antiderivative of sine u is just negative cosine of u. Second, it's important to change the limits of integration when you change the variable, because failing to do so is an error. If you do that, the expressions on both sides of an equal sign are not going to actually be equal. So, for example, in this integral, 2x sine x squared, going from 2 to 4, since we used the substitution u equals x squared, we actually had to square the original values in the limits of integration. That's because those were values of x. So when we changed the variable to u, we had to convert them into equivalent values of u. Third, the best strategy is usually, but not always, to let u be the inner expression. You want to identify some inside expression and let u be that. Or if it's a rational function, choosing the denominator often works. But I need to make it clear, these are not hard and fast rules. They're just general guidelines. Neither rule works all the time. And to some extent, u substitution is a bit of an art that just takes practice. Fourth, sometimes you have to perform double substitution. This is where you have to manipulate the variable u in order to get rid of some of the x's in the original integral. I'll just refer you back to this example that we did, which demonstrates the principle. And finally, when you've converted an integral from x into u, the resulting integral must have only the variable u. The whole point is we're trying to change the entire integral from one variable to another. So, for example, the integral x square root of u du contains both x's and u's, and this is just automatically wrong. You really have to pick a lane here. You can only have one variable in the integral. By the way, I had mentioned at the beginning of the video that I would tell you where I was standing on that boulevard. That boulevard is in Reseda, California. Reseda, California is the setting of the 1980s movie The Karate Kid. That movie happens to have the discussion between the two main characters that's directly on point here. This is where Mr. Miyagi is telling Daniel that if he's going to study karate, he just has to actually do it or not do it. He can't go sort of like, yeah, maybe I'll study some karate, maybe I'll not. It's just the same here. You can't form an integral and say, maybe I'll have some x's, I'll have some u's. I don't know, we'll mix them up together. You just can't do that. So I'm going to let Mr. Miyagi and Daniel take us out of here and speak for themselves.